When people ask if we are alone in the universe, they usually point to the Drake equation. They count the billions of stars, the billions of planets, and conclude that mathematically it's impossible for us to be alone. But as a physicist, when I look at the equations of cosmic horizons and quantum information, I come to a very different, much more chilling conclusion. The question isn't whether life arose somewhere else in the infinite expanse of space. The question is whether the universe's geometry allows two intelligent observers to ever exist in the same bubble of time. Today, I want to show you why the laws of physics, specifically the speed of causality and the horizon problem, are intentionally set up to keep intelligence fundamentally, logically, and completely isolated from itself. Now, look, let's be very precise here. When popular culture discusses this, they frame it as a biological problem or a chemistry problem. They talk about amino acids in a primordial soup, or the statistical likelihood of a planet landing in the Goldilocks zone, where water doesn't instantly boil or turn to solid ice. But that's thinking too small. It's a bit of a nuisance for our sci fi fantasies, but the real restriction isn't chemical, it's structural. The universe doesn't use biology to keep us apart, it uses the fabric of space time itself. Let me walk over here to the chalkboard and sketch something for you. Don't get confused by the popular science version of aliens, where they just hop into a starship and warp across a galaxy. Physics doesn't allow shortcuts with the ledger of reality. I'm drawing two diagonal lines here, intersecting at a point. This is a standard Minkowski light cone. Imagine this point right at the apex is Earth right now. The region inside these lines represents our past and our future, everything we can ever see and everything we can ever influence. Now, let's imagine a completely separate planet, billions of light years away, where another intelligent species has evolved. I'll draw their light cone over here. Notice how, if we place them far enough apart in an expanding universe, their paths never intersect before the horizon takes over. They are ghosts to us. Or more accurately, we are ghosts to each other, because the geometry of the universe ensures that the information describing their existence can never, even in principle, reach our senses. The point is actually quite subtle, you see. We think of existence as an absolute statement. We say, if a star exists out there, it exists whether I look at it or not. But quantum mechanics and general relativity tell a much harsher story. Existence, in a deeply physical sense, requires the capacity for interaction. If an entity is so far removed from you that not a single photon, not a single gravitational ripple, not a single subatomic psi can traverse the gulf between you before the expansion of space carries you away at superluminal speeds, then that entity is not part of your universe. It is outside your causal reality. This brings us to what physicists call the causal diamond. It is a beautiful, brutal mathematical concept. The causal diamond defines the absolute boundary of what is real for a specific observer. Imagine tracing all the light rays that could have reached you from the beginning of time, that forms your past light cone. Now trace all the light rays you could possibly emit from this moment until the infinite future, that forms your future light cone. The intersection of these two regions, the overlapping shape where your past can inform your future and where you can actually interact with the cosmos, is a diamond. If an event occurs outside your causal diamond, it doesn't just mean it's hard to see with a telescope. It means that from the strict perspective of quantum mechanics and relativity, it has no causal connection to you whatsoever. It does not exist in your universe because no bit of information can bridge the gap. Now, let's step up to the board and look at the mathematical skeleton of this diamond. The boundary of this region is governed by the metric of spacetime. In an ordinary flat Minkowski space, the light cone extends forever. But we do not live in an empty flat sandbox. We live in a Friedmann-Lemaitre-Robertson-Walker universe, a space-time that is dynamic, stretching, and governed by the distribution of energy density. When you solve the field equations for an expanding space, you find that the total distance a photon can travel since the Big Bang is strictly bounded. This is the particle horizon. But there is a second, much more terrifying horizon, the event horizon. It marks the boundary of events that can ever send a signal to us, even if we wait for an infinite amount of time. The finite speed of light, which is really the speed of causality, the absolute speed limit at which any event can affect another event, acts as a hard, impenetrable wall. Because the universe is expanding, and because that expansion is accelerating due to the cosmological constant, the size of our causal diamond is shrinking relative to the rest of the cosmos. Most of the universe is already fundamentally outside our reach. It has slipped beyond our cosmic horizon. Even if there are 1 trillion civilizations thriving right now in the distant reaches of the cosmos, the geometry of space means they are trapped in their own diamonds, and we are trapped in ours. For all logical physical purposes, we are completely alone in our bubble of reality. But it gets even more depressing when you consider the thermodynamic balance sheet. Let's follow that quantum logic to the chalkboard. To understand why intelligent life is so devastatingly isolated, we have to look at what life actually is from a purely physical perspective. Life is not a magical spark. Life is an engine that processes information. More specifically, it is a highly ordered, local pocket of incredibly low entropy. Now, we all know the second law of thermodynamics. The total entropy, or disorder, of an isolated system must always increase over time. The universe hates order. It wants everything to be a lukewarm, featureless soup of radiation. It wants to decay, to smash things down into their most boring, disorganized states. So, how does an intelligent observer, a brain capable of contemplating the cosmos, exist at all without violating this sacred law? The answer is that you have to pay for it. The ledger must balance. To create a small, highly organized system like a human being, a brain, or a global civilization, you have to dump an astronomical amount of disorder into the surrounding environment. Life is a heat engine that takes in high-quality energy and expels waste heat, driving up the entropy of the wider universe. To get just one intelligent observer, the universe has to waste an unimaginable amount of space, matter, and energy. You need a massive heat bath around the low entropy pocket to absorb all that chaos. Let me draw this out for you mathematically. Entropy, in the language of Ludwig Boltzmann, is a measure of microstates, the number of ways you can rearrange the microscopic components of a system without changing its macroscopic appearance. The equation is elegant. S equals K log W. A high entropy state is easy to achieve because there are trillions of ways to make a chaotic mess. A low entropy state, like the specific molecular arrangement of a working biological brain, has a microscopic configuration that must be precisely tuned. It is an incredibly small target in the space of all possible configurations. Think about the sheer scale of the waste required to hit that target. Billions of years of burning stars, supernova explosions, collapsing molecular clouds, and barren planetary surfaces, all just to produce a single planet where a handful of conscious minds can sit around and do calculus. Intelligence is an incredibly expensive commodity for the cosmos to manufacture. The thermodynamic cost of creating a single intelligent observer is so high that the universe simply cannot afford to cluster them together. Statistically, the creation of one civilization requires such a massive, localized drain on the available order of a cosmic region that it effectively sterilizes the neighborhood, leaving coexisting civilizations as a profound statistical anomaly. Now, don't get confused by the popular science version of aliens who build galactic empires. Let's look at the actual numbers behind this cosmic fine-tuning. because this is where the physics becomes truly staggering. We have to talk about the cosmological constant, denoted by the Greek letter lambda. It represents the energy density of the vacuum of space. When we try to calculate what lambda should be using our best quantum field theories, summing up the zero-point energies of all the quantum fields in the vacuum, we get a value that is absurdly large. It is roughly 120 orders of magnitude larger than what we actually observe in our universe. This is often called the worst prediction in the history of physics. If the vacuum energy were even slightly closer to that theoretical value, if it were changed by just one part in a decimal point followed by 100 zeros, the universe would have met a violent end before it ever began. Space would have ripped itself apart at such a catastrophic rate during the earliest fractions of a second after the Big Bang that matter could never have coalesced. Atoms wouldn't have formed, stars wouldn't have ignited, there would be no chemistry, no planets, and certainly no physicists standing at chalkboards. The fact that our universe has a cosmological constant that is finely tuned to be so incredibly small, yet precisely non-zero, means our existence hangs on a knife's edge. It implies that the conditions allowing for any information processing at all are an incredibly rare quantum fluke. We are living in a highly unusual, hyper-specific pocket of cosmic history where the vacuum energy hasn't completely torn our timeline to shreds. Let's go a step deeper into the quantum nature of space-time itself, because there's another constraint that popular science completely ignores: the holographic bound. This principle, which grew out of our attempts to understand the thermodynamics of black holes, states that there is a fundamental limit to how much information can be packed into any given region of space. It turns out that the maximum amount of information you can cram into a room, a planet, or a galaxy isn't determined by its volume, but by its surface area. Let me write the formula down so you can see exactly what I mean. The maximum entropy, or information capacity I, of a region enclosed by a boundary area A is given by the Bekenstein-Hawking formula, I less than or equal to A over 4 times the Planck length squared, where the Planck length is the Planck length. Look closely at this. The denominator contains the Planck length squared, an unimaginably small area. This bound tells us that if you try to exceed this limit, if you try to pack too many bits of information, too many high information, highly complex systems into a localized volume, the physics breaks down, or rather, it protects itself. The region becomes so dense with information and energy that it undergoes gravitational collapse and forms a black hole. Now consider what an advanced intelligent civilization is. It is a massive, sprawling network of high-density information processing. It builds computers, modifies environments, channels stellar energy, and generates immense amounts of data and complexity. The holographic bound tells us that the universe cannot physically sustain an infinite density of these high information systems close to one another. There is a structural limit to the complexity of a cosmic neighborhood. If you had multiple highly advanced civilizations trying to coexist and exchange massive quantities of information across relatively small distances, the local spacetime fabric simply couldn't support the sheer density of that information without severely warping the local geometry. The universe enforces a sort of cosmic zoning law via the holographic bound, ensuring that these rare, hypercomplex nodes of intelligence are spaced incredibly far apart, separated by vast empty deserts of low information vacuum. Let's step back and look at the dynamic picture of our universe because things are actively getting worse. The horizon problem isn't static. Because of that tiny but potent cosmological constant lambda, our universe isn't just expanding, that expansion is accelerating. Every single second, the space between galaxies is stretching faster and faster. Right now, as I stand here, distant galaxies are being pushed away from us. Eventually, their recession speed will exceed the speed of light. Now, don't misunderstand, this doesn't violate relativity because it's space itself that is stretching, not the galaxies moving through space. But the practical consequence is devastating for the prospect of cosmic companionship. It means that even if we have neighboring civilizations out there right now, just beyond our current reach, they are actively being erased from our future timeline. They are redshifting out of existence. Their light is becoming longer, fainter, and less energetic until eventually it will stretch to infinity and vanish completely. The cosmic expansion is a one-way conveyor belt carrying information out of our causal diamond, dumping it over the edge of the cosmic event horizon where it can never return. We are living in a brief cosmic window where we can still see the remnants of the early universe. If we wait long enough, the accelerating expansion will push every single galaxy outside our local group completely out of sight. The night sky will go completely dark, leaving future generations, if there are any, with the illusion that their immediate galaxy is the entire universe. The universe is actively segregating itself, cutting ties, and burning the bridges of information exchange between its various sectors. Let's look at this through the lens of black hole complementarity and the retention of quantum state information. If information cannot escape a horizon, then two observers separated by a horizon cannot share a quantum state. They cannot be entangled in a way that allows for meaningful classical coordination. They are decoupled. In physics, when two systems are completely decoupled, treating them as part of the same operational reality is a logical error. The Drake equation assumes a flat, accessible Newtonian stage where you can just count up all the players and imagine them interacting. But the stage isn't flat. The stage is breaking apart into isolated shards. Consider the nature of a quantum measurement. To make a measurement, an observer must interact with a system, causing decoherence, where the quantum possibilities collapse into a definite classical reality. This process requires an exchange of photons, a physical coupling between the observer's instrument and the system being observed. Now think about what happens when two potential observers are separated by an accelerating cosmic horizon. No photon can cross from one side to the other. This means that from the quantum mechanical framework, the observer on the other side of the horizon cannot perform a measurement on our system, nor can we perform one on theirs. We inhabit two entirely distinct Wheeler-DeWitt wave functions of the universe. To talk about them existing simultaneously with us is a fundamental violation of the quantum mechanics of open systems. If there is no possible experiment, no possible interference pattern, and no possible thermodynamic exchange that can link our two systems, they are not part of our reality. They are mathematically orthogonal. Let us think deeply about this isolation. It is an intrinsic characteristic written into the very laws of gravity and quantum mechanics. When we look out at the deep field images captured by our modern space telescopes, we see thousands of beautiful, swirling galaxies, each containing hundreds of billions of suns. It looks like a garden, teeming with possibility, but the physics tells us that this visual abundance is an illusion of timing. We are looking at light that left those stars deep in the cosmic past, back when the horizons were wider and the space between us had not yet stretched to its current insane proportions. We are looking at a history book, not a current map. Many of those galaxies we see are already, at this very moment, completely beyond our event horizon. If we were to launch a beam of light toward them right now, it would never arrive. They are already dead to us. cut off from our future light cone by the relentless expansion of the vacuum. So where does that leave us? When you add up the balance sheet, the structural prison of the causal diamond, the extreme thermodynamic cost of creating a low entropy observer, the precise fine-tuning of the vacuum energy, and the strict information limits imposed by the holographic bound, the conclusion is inescapable. The math isn't telling us that life is common and we just haven't looked hard enough. The math is telling us that isolation is a core, fundamental feature of cosmic geometry. The universe is designed by its very laws to keep its conscious minds from ever holding hands. But this shouldn't be viewed as a tragedy. It's easy to feel a sense of existential dread when you realize that we are likely the only intelligent observers who will ever inhabit this particular bubble of space-time. But look at it from another perspective. It gives our existence a profound, almost overwhelming weight. We aren't just one mundane species among millions of galactic empires in a crowded sci-fi universe. We are the sole guardians of consciousness within our entire causal reality. We are the only instrument through which our bubble of the universe can observe itself, understand itself, and formulate the very laws of physics I've been writing on this board. If we fail, if we destroy ourselves through our own cosmic short-sightedness, that light goes out permanently. There is no backup civilization coming from the stars to save us or to carry on the legacy of mind. When our cosmic horizon finally closes in and the accelerating expansion isolates our local space entirely, the only thing that will matter is whether we manage to keep the flame of consciousness alive inside our diamond. It is our absolute cosmic responsibility to understand these laws, to respect the boundaries of our geometry, and to survive. Because in this vast, cold, beautiful, and lonely architecture, we are the only ones here to appreciate the show.